Hello everyone, welcome back. Today we're going to discuss the place for Java among other different languages. Java itself were invented like 23 years ago in 1995. This is approximately how the computers looked like back then. Let's say you're a developer and you have this ideal world. You picking up the language that you know, and then there is a magic, this special magic that is known as WORE, and this basically magic allows your program to run anywhere, to any possible platform, therefore to any possible hardware. And by the way, this WORE stands for write once, run everywhere, or time to time, write once, write anywhere. Now, there are several ways to reach this ideal world. Way number one, using native high-level languages like C++. And if you're not going to catch some of the definitions from this slide, it's okay, we're going to discuss it right immediately after. The second one is bytecode languages like Java and Scala, and the third way is actually scripting languages like the Python. So let's discuss what does it mean to be a native language. We'll start with native language, and in order to give you some explanations, I will use some terminology. I will explain how the development going for each of the language. I will show how you distributing the program after it's been developed, and I will show how the program actually executed by the end customers, and the actual difference among these three things. So let's start with native language. When you have a native language, you write a program. You basically has a text editor where you're writing a program that will be executed on a particular machine. And then during the development cycle, this is very important, you're running a special program that has named a compiler. And this compiler basically takes in your program and creates a binary. Binary is a platform-specific file. It can be executed only on a particular platform, and that is the binaries that you are actually redistributing. The key problem here that you need a binary for each particular platform. You do need to have a different compilers, usually different compilers for different platform, and usually it's actually really problematic to compile one program for different platforms. The good thing that this binary that you have compiled will definitely be executable on the platform that you compile it for. So just summarize. Positive stuff. It's fast because compiler can optimize precisely for the platform that you're compiling it for. Negative part, actually portability. You cannot compile for the macOS and then run it on Windows or vice versa. And often there is no compilers that are supporting all popular platforms. Usually you have a better support for Windows or better support for Linux, or time to time it's just different support. You will see that a lot of native program has a special hacks that basically saying, oh, if you're compiling me for macOS, do compile that part of source code. Compile me for Windows, do execute that part of the source code. So this overall kind of complex for the developer to write something that will be compilable everywhere, even if it's possible. The second one is a script language. Script language starts with the similar thing. You're writing your program, right? This is just a text file, and the good part that you're distributing the same text file. You're not doing any compilation, you don't do anything. You're literally pressing Command S, saving the file, opening your email client, and sending this text file to whoever you want to distribute this program. That's it. That's literally it. Everything happens on the client side. The client actually do need to have a special translator that will take this program as an input and will convert this program to executable on that particular operating system. As a result, the positive thing here is portability. As I said, as a developer, you don't need anything else, just an editor, text editor. Negative side, first of all, it's slow. It's usually the slowest possible solution for the program because the client actually do need to execute translation of your program, and human readable program is the worst case for the machine. It's actually need to take time to convert it to the executable format. Now you have a language log because this program is logged for the language that you have used to write it. You cannot use another language and let's say add some module or function or class or anything. You literally locked with the language that you decided to start writing it with. And plus, it requires special additional software on the client side. In the case of native application, double-click it, all you need to do to start it on the client side. Here you actually do need a translator, and the client do need to know how to use it. And the last way to this ideal world is a bytecode language. It's kind of intermediary. The key here that during the development, when you have the final version of the program that you do want to distribute, you're running a special bytecode compiler. Bytecode compiler creates a bytecode representation. It's kind of intermediary representation. The key here that bytecode is as close to machine code, executable code as possible, and at the same time it's platform independent. This is a very important part. Essentially, it also requires a special translator on the client side that will translate this bytecode to the actual executable code on each particular platform, because executables codes, they are different for each particular platform. However, it's not that slow as with the case of scripting languages, because bytecode tries to be as close to the hardware executable code as possible. Therefore, it's reasonably fast, reasonably. And now you can actually execute after the translation on any particular platform. Summarization, positive. This gives us a portability. You can execute this bytecode everywhere. This is platform oriented instead of language oriented. The negative part is actually slow. Not as slow as the script languages, but it's still kind of slow because you still have this translator. You can translate once and then execute it again and again. It will be almost as fast as native, but still. And the last part, as I said, it do need this special translator, which is called virtual machine, for the bytecode on the client side. Now, we have discussed in a summary 3 ways that the humanity right now have to achieve this magic situation when you're writing once and it runs everywhere. Native languages that requires a lot of work to make it cross-compilable, but usually doesn't require to have anything on the client side. Bytecode that requires the client side to have virtual machine and use special compiler that translate your source code to intermediary representation that is very close to the executable code. And the script language, which is essentially just a text file that you're redistributing, and the client need to have special translator from this script language to executable code. And the Java is here. I hope you all already have realized it by now. Okay, so this is basically where Java stands among any other languages and why exactly the Java choose this path. Now I want to say thank you, and I hope to see all of you back at the next lecture. Thank you, bye bye.